Welcome back to the deep dive. Today, we're going way off the grid. We're analyzing a device that's built for isolated places.
That's right. We're looking at the NTI E-AVDS-4G4-P 4G automatic voice dialer.
And our mission for this deep dive is to figure out how this specific device acts as a critical communication link where normal infrastructure just isn't an option.
Exactly. We're talking about places where you can't just run a phone line. It's either impossible or just way too expensive.
Okay, so let's unpack that. At its core, this NTI device is basically a rugged little alarm sentry.
Right. It sends out automatic voice calls and SMS alerts, but it does it all over the cellular network. No landline needed.
So if you have a critical asset somewhere remote, like a pump station or a pipeline valve, this is how you know when something goes wrong.
And the whole alert system is built for speed and redundancy.
Yeah.
It triggers the moment a connected sensor goes outside of a set range.
A set range, so like a door opening when it shouldn't.
Exactly. A door opens, humidity gets too high, a battery voltage drops, anything you can measure with a sensor.
Yeah. What's really crucial here, I think, is the multi-recipient part. It doesn't just ping one person.
No, it can call or text up to 8 separate phone numbers.
8, wow. Okay, so you're building a whole response team into the device itself.
You are. But there's a key point on the messaging itself. It's very concise.
How so?
It stores one outgoing voice message, and it's a tight 20 seconds. And the SMS is limited to just 70 bytes.
I mean, that's short. It forces you to get straight to the point.
It does. It's for machine-to-person action, just the critical data. And of course, you do need to provide your own mini SIM card for it to work.
Right. Okay, so while the message size is tight, it all hangs on how well this thing can actually connect. That brings us to the tech specs. Is all this network compatibility, is it overkill or is there a real need for it?
Well, that versatility is the entire point. The big takeaway is that it supports the whole spectrum of global 4G LTE bands.
And if 4G isn't available?
Then it just gracefully falls back to 3G or even 2G. So basically, if there's any kind of signal out there, old or new, this device is built to find it.
So connectivity is solid. What about its physical resilience? Can it handle being out in the middle of nowhere?
It's definitely tough. It comes with its own 12-volt power supply, and the operating temperature range is pretty wide. We're talking 39 to 140 degrees Fahrenheit.
That 140-degree number is important. That means you can stick it in a metal shed in the desert and not worry about it.
Exactly. Or on a snowy mountaintop. It's designed to keep working.
And how does it plug into other systems?
Integration is also really flexible. It interfaces with controllers like the E-AVDS LXO through simple output relays.
Okay.
And it supports both normally closed and normally open circuit connections. That's a huge deal.
Why is that so important?
Because it means it can plug into almost any existing industrial sensor, no matter how that sensor is designed to work.
Got it. So wrapping up with the commercial details, what are we looking at?
The price today is listed at $250, and the part number is E-AVDS-4G4-P.
And that includes a few perks, right? Free shipping in the U.S., a 2-year NTI warranty.
And it's also TAA compliant. That might sound like just paperwork, but for any big utility or government job, it means it's pre-approved for use.
Right. That can be a major hurdle cleared.
If you zoom out for a second, what this device really is a commitment to keeping an eye on things in hard-to-reach places.
It's simple, but the connectivity is incredibly robust.
Exactly. It solves a very specific problem, getting critical data out reliably and affordably when you just can't run a physical wire.
So what's the bottom line for you, the listener? The NTI E-AVDS-4G4-P is a dedicated, self-sufficient monitoring hub. It's built specifically to work around the limits of traditional infrastructure.
And you make sure those critical alerts always get through, no matter how remote your assets are.
And that leaves us with a final thought to mull over.
So since this device uses common cellular networks to manage infrastructure, things like pipelines or remote weather stations, think about this. How does this kind of simple, low-cost monitoring change the economics of managing those assets? Does it make those specialized, really expensive satellite systems almost obsolete for most industrial uses?